This question's about standard treatment for a certain disease, where 9.7% of patients with the disease experience side effects within 1 year. And then a new treatment comes along, a random sample, 450 patients with the disease was selected, and then we're interested in the number of these that have side effects. Because potentially, and you can see later on, we're going to be interested in whether the new treatment's better. To start with, though, it's asking about an assumption needed in order to use a binomial model for X. Now, the key thing is you've got to give context here. You can't just be thrown out the standard phrases such as events need to be independent or the probability needs to be fixed. It needs to be constant, it needs to be the same throughout. You can't really just say, it needs to be like either success or failure. You need to relate it to the problem. Now, this is what the mark scheme accepts. So here I'm basically saying the probability is constant, but I'm saying the probability of side effects is the same for each patient. Okay, it's not like an average overall, so I'm giving context. Or the patients are independent. They're very close to just saying events are independent, but it's actually relating it to the question. One also it talks about in the mark scheme is that the patients form a random sample of the population. Other answers will be accepted as long as they make sense and they are related to the question. I think it will be accepted if you say, well, you might some sort of tests of side effects may be inconclusive. I don't know, that could potentially be argued, but I would probably, when I'm doing this sort of question, I would probably stick to the independent or fixed probability bit, but make sure I give context. Okay, 11b. It can be a confusing topic in stats. The flip side actually is it's not too bad to like learn the kind of method that's going on. It's sort of the same thing every time. It's a lot of marks, but it's the same kind of process. So we're testing at the 10% significance level whether the proportion of patients experiencing side effects within 1 year is greater under the new treatment than under the standard treatment. So actually we're looking at whether the treatment's worse, I suppose, in terms of side effects. Right, first thing we do is we create a null hypothesis. And that is to say that the treatment's exactly the same. You don't need to write null hypothesis, we use H0 for that. And it's going to be P is equal to 9.7% or 0.097. Now, you do need to say what this P represents. And it's the proportion of patients experiencing, quite a lot to write here, but you just need to define it. Proportion of patients experiencing side effects within 1 year. This is us basically saying that nothing's changed. In the new treatment, we're still getting the same percentage of people having side effects. H1 is then that the probability has increased because we're looking at a larger proportion of people getting side effects. So P is greater than 0.097. And this, I would just remind myself at this point, makes it one-tailed rather than two-tailed, which would be not equal to. All right, that's how we start it out. We then need to say what the binomial model is under H0. Under H0, X will follow a binomial distribution, assuming all the assumptions we've made are valid. And we've got 450 patients we're looking at, so we've got 450 trials essentially. And then we're assuming that 9.7% of them will have side effects. So our probability is this P is 0.097. Now, what we do is we look at the probability that, so it's found that 51 of them were found to have side effects. What we do is we look at the probability, not just that 51 of them have side effects, but 51 or more have side effects. And then we need to figure that out and find out if that was likely to happen or unlikely to happen. Because if you just set it equal to 51, that's not very likely. But if it's 51 or more, then you look at the whole scope of it. To work this out, we need to change it to 1 minus the probability that x is less than or equal to 50. Because here, basically, I've got everything that's beyond 51. So basically, I need to take the whole spectrum, but then minus everything to the left of 51. So basically 50 onwards to the left. Because our calculator can deal with that, we can put it in. I'm not going to do that right here. It's you should know to look at the binomial CD button, and then it's going to be 1 minus 0.86169. I'm going to write it out to 5 places, is equal to 0.13830. And crucially, this is greater than 10%. What does this mean? This essentially means the probability of 51 or more of the patients experiencing side effects within a year is about 14%. There's not a large chance, but there's an all right chance that it might happen, and that chance is larger than my significance level. So we say basically that it could have happened because of natural variation, and essentially we're going to accept H naught. Like the contrast is, if it was really small, if it was like 0.01, that would be 1%, then it would be very unlikely to have happened by just natural variation. But it's less than 10% chance, and we would then say, actually, you know what, the original hypothesis wasn't correct. In this case, it's larger than 10%, so we actually accept the original hypothesis. We accept H naught, and we just need to give some context now. There is insufficient evidence. You can say at the 10% level if you like, I'm not going to do that here. Insufficient evidence that the proportion of people with side effects after 1 year has increased. You do need to write some context at the end of this extra 1 mark. There's quite a lot to write, but it's like really clear in the mark scheme about what you get the marks for, writing down your hypotheses, defining P, writing down a binomial model, working out the probability, comparing it with the significance level, accepting H naught, writing a conclusion. These, with context, these are the things expected.